All right, this is a very simple application of the chain rule. Let's see how we can do it. We know that the derivative of x cubed, if we ignore this stuff inside the brackets, it's kind of like x cubed. We know the derivative of x cubed, it's 3x squared, right? So how can we use that understanding to do the derivative of this more complicated looking expression? So let's pretend that we ignore the 5x to the 4 plus 2 and just think of it as something to the power of 3. What is the derivative of something to the power of 3? Well, it's 3 times that something squared, but not just that, times the derivative of that something, okay? This is the essence of how the chain rule works. We know the derivative of x cubed, it's 3x squared, right? So this is kind of the same, but instead of just simple old x, instead of that in there, we have this more complicated looking thing, 5x to the 4 plus 2. And the way we handle that is we kind of treat it the same way, but one big difference is at the end we have to multiply by the derivative of that, right? So let's fill in what we were ignoring there. We were ignoring 5x to the 4 plus 2. Now, when you look at this, you should say to yourself, this part is done, okay, because there's no derivative signs in it. But over here, this still needs to be worked on because we still have a derivative sign to take. But now it's pretty easy because the derivative of 5x to the 4 plus 2, that's just the derivative of a polynomial, and we've practiced that. So let's recopy what we have here that doesn't need to be worked on anymore. And then let's finish it off by multiplying by the derivative of this. To find the derivative of this, it's easy. 5 times 4 is 20. X to the power of 1 less, so x to the 3, plus the derivative of 2, which is just plus 0. So I won't even bother writing it. The derivative is now done. We should really just do a obvious little simplification here. We can multiply 3 times 20x cubed to get 60x cubed. And this other factor just stays along for the ride. And there's our answer. All right, so that's a very simple application of the chain rule for derivatives.